Let's start out with 2 and see how far we go.
Some of them and other ones I have like no idea where to start.
Okay.
Or what problems did you finish? I did 53. I did 59. Then I stopped. Oh yeah, I got 59. Actually.
Okay, so I'm going to do 47 to start out, okay? 47 on page 126.
Oh wait.
Okay? So y is equal to 3, 1 minus sine x over 2 cosine x. So you're going to use a quotient rule here, right? Right? Quotient rule. Which means you're going to keep 2 cosine x and you're going to differentiate 3 times 1 minus sine x. Hang on, let me make sure everybody's there. You're going to differentiate 3 times 1 minus sine x. You with me on that? So what would you get, Tati? Why 0? 3 will turn into 0, but what about minus 3 sine x? Okay, what you're going to do is, well, let's go rewrite this, okay? Let's rewrite it like that. Okay, let's rewrite it like that. So you're going to keep the 2 cosine x alone, and you're going to differentiate 3 minus 3 sine x. What do you get? Negative 3 cosine x minus, you're going to keep the top alone, so the top is this, and you're going to differentiate the bottom. What's the derivative of 2 cosine x, John? Negative 2 sine x. Is everybody there? Yeah. And then the bottom becomes 4 cosine squared x. Is everybody okay with the bottom then?
How come the constants will go away? For 2. Yeah. Doesn't it turn out 0? That's what I was here. Oh, because it's a whole.
No, I'm using the other constant rule, right? If you have a function that's like this, a times another function, then the derivative of is just equal to a times the derivative of g. So pull the constant out in front. That's different from finding the derivative of just a straight out constant function. That's different. Okay, this is not just a constant function, it's a constant times another function. Okay. Okay, is everybody caught up on this? Yes? Okay, let's go distribute stuff out so you get minus 6 cosine squared x plus 6 sine x minus 6 sine squared x. Did I do that right? Is everybody caught up on this? Yes? All I've done is distributed the 2 cosine x and the negative 2 sine x. I've just multiplied that stuff out. Is everybody okay on this? Are you guys alive? Okay. If you were to combine this thing here and this thing here, what would you get?
1.
Negative 1. Negative 6 actually. Because there's a minus sign there. So this would actually become negative 6. If you factor it, you get that. So everybody with me on this? Okay. And then this guy stays as is. Kritik, can you close the door there? Is everybody with me on this? Yes, is everybody okay on this thing? Benjamin, you good? Okay, so do you guys all agree this is 1? Yeah, so then this becomes minus 6 plus 6 sine x over 4 cosine squared x. Did they leave it as that or did they do something else beyond that? Can you take a look? What does it give you? Okay, so they've done a little bit more simplification. I don't know if we need to go there, but let's try it, okay? So what they've done is it seems like they've taken this and divided that out. So you get minus 3 over 2 cosine squared x. Yes? Plus 3 over 2 sine x over cosine squared x. Sorry? Oh, you mean at the top? They didn't? By 4 cosine squared x? Yeah, frankly, to me, you could have left your answer as this, and this is good enough for me. How would you check whether this answer is correct versus the books? How would you check? Plug in where, what? Sorry? I don't think that's a good idea. I mean, you'll have to use a calculator, but what would you do? Yeah, exactly. You'd put your answer, let's say, in y1. You'd put their answer in y2 and graph it and see if the two are the same. Yeah? Guys with me on this? Do it. Do it. Take my answer and put down their last answer, which is 3 over 2 sec x parenthesis 10x minus sec x. Their last answer.
I did not get the same graph. I didn't either. Me neither.
Okay, which one did you put in?
Yeah, both of them.
Wait a minute, there are 3 answers at the back. Which one of those 3 did you put in?
Oh.
Oh.
Are we supposed to do?
What time does the bell ring?
30.
Okay, yeah, 29?
Yeah.
Are you kidding me? I have 9 minutes to do one topic, okay? So let's hold off on this one and we'll come back. I want to do 2.3, and those people who need to know that, we can move on. So let's go ahead and do the lecture, and then if you need, and we'll have time on Monday to go over more homework, okay? So don't fret about this. Where are we? We are on 2.3. To get f triple prime and so on. So you can go on and on and on and on, okay? In terms of differentiating it. So what I want to do is I want to relate higher order derivatives to what we've done before, okay? We've all done your position function. Remember, you've had equations that look like this. Negative 16t squared plus 16t minus 1,000, okay? When you're talking about dropping that thing from remember that? From the top of a building? So those are the kind of equations that you've seen before. So that's called a position, right? It tells you the height of the coin, say from the ground. If you differentiate it once, you get velocity, okay? And notice that the velocity is a function of time. So you can differentiate it again. If you differentiate it again, you get what's called the acceleration function, okay? So you get position, you differentiate once, you get velocity, differentiate again, you get acceleration. Shouldn't it be what? This should be S double prime. This one here? Yep. Thank you. Okay? All right, so using that knowledge, I have 2 problems to do, so I better get through them, okay? Let's quickly take a look at example 10 on page 125, okay? They give you the position function is st equals negative 0.81 t squared plus 2, okay? If you differentiate once, what do you get? What do you get? What's the derivative function? Sorry? Negative 1.62t Okay, so this is velocity.
Is that E1?
Yes. And if you differentiate one more time, what do you get? Negative 1.62. And the units that they're using are meters, and so this is meters per second squared. What are the units for velocity? Meters per second. And position? Just meters. Okay? So all they're trying to do in this equation is teach you that the gravity on the moon is different than the gravity on the Earth. Everybody knows that. Okay? Gravity on the Earth is negative 9.81 meters per second squared. Okay? So if you take a look at the ratio, so you've got Earth over moon, the gravitational force or the acceleration, is equal to negative 9.81 over negative 1.62, which is about 6. And from your physical science, you should know this, okay? You should know that the gravity on the moon is about 1/6 of what it is on Earth. That's why those guys were hopping like mad when they went up there in '69. Okay? Has anybody ever seen that Apollo 13 and landing on the moon? The Eagle has landed? One of the most awesome movies ever. I was at NASA Kennedy Space Center about 2 years ago. And I went to see some movies there, and honest to God, I had tears in my eyes and I had goosebumps. It was that impressive. And to me, what's sad is it looks like that era of American science and technology is kind of slowly disappearing because we don't have another national goal. We don't have a goal to go anywhere outside Earth. We can't even forget going outside Earth. We can't even fix our own freaking problems here on Earth, man. Let alone going outside Earth. It's, oh my God, it's just...
Let's fix them first, and we can go into
no, on the contrary. On the contrary. I mean, you can imagine that if the European discoverers hadn't traveled and discovered things, we'd still be in the caves. I mean, I don't want to go into that because there are different... page 125 is a table that gives you notation of different derivatives. You can see I'm racing against the clock here, okay? Monica, why are you stressed? You're not even doing math, girl. I'm the one who should be stressed because I'm doing all the work. Yeah, but why? What? What? Oh, Charlotte told me it was easy. Okay, you guys take a look at table on page 125, different notation, okay? You get y prime, y double prime, y triple prime, and so on. In other words, all it's telling you is that you can differentiate a function more than once. That's all it's telling you, okay? All right, last example. And you'll need this for your homework tonight, okay? So number 125, page 129. So you're given a function y equals 1 over x. You're told that x is greater than 0. And they're asking you to show that that equation satisfies this differential equation. And I'll explain to you what a differential equation is. Okay. So first of all, does everybody see that this is an equation? It's got an equal sign in there. It's an equation. Now it's a differential equation because you have derivatives. Here's a derivative. What order derivative is that? What order? The first order? First order? No, we're not talking about a velocity anymore. We're talking about the order of derivatives. And this one here, second order derivative. So see how you've got derivatives that make an equation? And derivative comes from the word differentiation. That's why this is called a differential equation. That's why it's called a differential equation. And all they want you to do is that this equation satisfies this differential equation. So start out. Before you differentiate, what should you do? Nice, x to the negative 1. What's y prime equal to then? Negative 1 times x to the negative 2. So everybody with me using the power rule? What's y double prime? So differentiate y prime now. Benjamin, pay attention here. Differentiate y prime. 2x to the negative 3, right? The negative 2 goes down, which timesing by negative 1 makes it a positive 2 times x to the negative 3. Reduce the negative 2 by 1. You guys with me on this? Yeah?
The negative 1 times the 0.
No, again, you're not. Okay, I think you guys are confusing the constant rule with a function being multiplied by a constant. When a function is being multiplied by a constant, you pull the constant out and then differentiate the function. Okay? Then differentiate the function. Otherwise, you'd have to use the product rule, and it makes no sense to use the product rule there. So all we need to do now is take these different things and plug them into this equation. So x cubed will stay as x cubed. In place of y prime, what am I going to write? 2x to the negative 3 plus 2x squared. Instead of y prime, what am I going to write? Negative x to the negative pi 2. So everybody with me? All I've done is plug and chug. What is this guy going to give me?
2.
And this guy? Okay? Yeah.
So if it's parentheses negative x to the negative 2, is it x times negative 2 and then you add the negative?
Which one? Where are you?
For the other side.
For this side here?
The other one.
This one?
No, that way. That way? Yeah, that one.
Yeah.
Negative x, negative 2.
Yeah. So this negative and this positive makes it a negative.
I know, but is it like, if x was a number, if x was 3, would it be 3 of negative 2 and then you add the negative side?
Yes. Yeah. Okay, so